So we have two objects, that is Earth and Moon. So let us have Earth and Moon. So in the question it's given that the mass of the Earth, that is m1, is equal to 6 into 10 raised to 24 kg, and mass of the Moon, that is m2, is equal to 7.4 into 10 raised to 22 kg. Also it's given that the distance between them, or the distance between the centers, that is small r, is equal to 3.84 into 10 raised to 5 kilometers. We have to find the value of gravitational force denoted by capital F. So we'll write this data in the given. So in the given we have the value of m1, we have the value of m2, and also we have the value of small r. But the value for small r is given as 3.84 into 10 raised to 5 kilometer. And kilometer is not the SI unit, remember. So what we'll do is, we'll write 3.84 into 10 raised to 5 as it is. But we know that 1 kilometer has 1000 meters. That is 10 raised to 3 meters. So we write 10 raised to 3 meters. But here we have 10 raised to 5 and 10 raised to 3. When we multiply 10 raised to 5 and 10 raised to 3, we get 10 raised to 8. So we keep 3.84 as it is, and 10 raised to 5 into 10 raised to 3 becomes 10 raised to 8 meters. And also in the question we have the value of capital G, which we normally take 6.67. But here it's given 6.7, so we take 6.7 into 10 raised to minus 11 Newton meter square per kg square. Now we have to find the value of force, that is capital F. So we have F is equal to question mark. Which formula are we supposed to use? And obviously we know the answer, that is F is equal to capital G m1 m2 upon r square. So we write the formula, F is equal to capital G m1 m2 upon r square. Then we substitute the values. So after substituting the values, just pay attention over here. We have capital G as 6.7 into 10 raised to minus 11. We have m1 as 6 into 10 raised to 24, and we have m2 as 7.4 into 10 raised to 22 upon. This is the most important step. We always tend to make a mistake over here. In the denominator we have r square. So we need not write 3.84 into 10 raised to 8 square. We have to write 3.84 into 10 raised to 8 the whole square, which is very important. Now in the numerator what we'll do is we'll multiply 6.7 into 6 into 7.4. The answer that we obtain is 297.48. What remains is 10 raised to minus 11, 10 raised to 24 and 10 raised to 22. In the denominator we open the bracket. So 3.84, the square of 3.84 that we obtain is 14.74, and 10 raised to 8 the whole square becomes 10 raised to 16. Now what we'll do is, this particular term that you see over here, 297.48, we can write it as 300. This is called approximation. So we write 297.48 as 300. Now 10 raised to minus 11 plus 10 raised to 24 plus 10 raised to 22, and this 10 raised to 16 goes into the numerator and becomes 10 raised to minus 16. So this is the term that we have over here. Upon 14.74, we approximate 14.74 and make it as 15. So here what we have is 15 ones are 15 and 15 20s are 300. So this is 20, and when we calculate this, when we add all this up, the answer that we obtain is 10 raised to 19. We also know one more thing, that this term 20 has to be between 1 and 10. But is 20 between 1 and 10? Obviously the answer is no, right? That means we need to shift decimal one place to the left hand side. So that means 19 plus 1. So we get 2 into 10 raised to 19 plus 1, which is 20. So the answer is 2 into 10 raised to 20, and the unit is Newton. And writing the final statement, the gravitational force of attraction between Earth and Moon is 2 into 10 raised to 20 Newton.